All right, so certain functions, certain, C-E-R-T-I-N, certain functions are even or odd. Certain functions are even or odd. Not all of them. Some are though, and so that's what we want to talk about. So if you have a function, and we're talking about function this time, right? So remember I could not talk about this as a function because that's not a function. It fails the vertical line test. This was a relation. But now we're talking about functions. Only functions can we talk about even or odd. So certain functions are either even, odd, or neither. All right, so we're going to talk about the neither part in a little while. All right, so if a function, if a function is even, if a function is even, and I'm going to tell you now that this function right here is an even function. This is an even function. All right, so let's think about that. So if that's an even function, can you tell me something about its symmetry? Well, it's symmetric about which axis? It's symmetric about the y-axis. So even functions, even functions, even functions, if a function is even, it is symmetric, symmetric about the y-axis. So an even function is symmetric about the y-axis. Okay, this right here, remember this one was symmetric about the origin, right? So if a function is symmetric about the origin, it's called an odd function. An odd function. And I want you to think about this. See, I call this an even function, right? What do you notice about the exponent of the x's? The exponent of the x's is even. So an even function. Odd function, what do you notice about the exponent here? It's odd. So that's an odd function. So an odd function is symmetric about the origin. So an odd function, so if a function is odd, it is symmetric about the origin. Okay? Now you may say, well, what about the x-axis? Well, remember, if it's symmetric about the x-axis, if it's symmetric about the x-axis, it's not a function, right? So we can't talk about, we can't do something like this and say x-axis, because remember, if it's symmetric about the x-axis, it's no longer a function. See, it's not a function, it fails the vertical line test. All right, so far we know this. We know that if a function is even, it's symmetric about the y-axis, and we know that if a function is odd, it's symmetric about the origin. So remember, an odd function, symmetric about the origin, reflected about the y-axis, then reflected by the x-axis. All right, now there's a test that you can use, just like we did with the symmetries for the x-axis, y-axis, and origin. There's a test you can use when you're dealing with functions. All right, so here's what I want to mention. Okay, so I'm going to call this right here f of x equal x squared. Okay, so if I do a t-table just to kind of do this discussion, if I let x be 1, then remember this is f of x. So f of x, same thing as y. And I find f of 1, I get 1 squared is 1. If I choose negative 1, f of negative 1, a negative 1 times a negative 1 is a positive 1. So the point's this. This is 1, 1. So 1, 1 becomes negative 1, 1. 2, 4, when you're reflected about the y-axis, becomes negative 2, 4. So to determine if a function's even, this is what you're going to do. To determine if a function is even, you're going to find f of negative x. See, negative 2. 2, negative 2. And then you're going to compare that with the y value. So its y value compared with the other one. So you're going to compare f of negative x with f of x. And compare with f of x. So if f of negative x equals f of x, then the function f of x is even. All right, so to determine if a function is even, you replace f of negative x with, you replace x with negative x. So you can compare f of negative x and f of x, and if they're the same, then it's an even function. We're going to come back and do a problem. It's not difficult. It's not difficult at all. It sounds difficult, but it's not. Now, here's what I want to do with this one. Odd function. So, 1, 1 became negative 1 when we reflected it. If I take 2, 8 and reflect it by the origin, it becomes negative 2, negative 8. So notice that when I reflected it by the origin, the y coordinates were opposites. 8, negative 8. The y coordinates were opposites. So here's the idea with odd function. To determine if a function is odd, find f of negative x. So just like with even, you're going to find f of negative x. Then you can compare with f of x. You're going to compare the two. And so here's the idea. If f of negative x equals the opposite of f of x, then your function is odd. Your function is odd. Now remember, I used the word opposite, right? I used the word opposite. Now remember a while ago, we said this. Let me find it real quick. Yes, this one. All right. So, all right. So remember when we did this one, this function. This relation right here was symmetric about the origin, right? And so I want you to notice that when I replaced x with negative x, y with negative x, every term was opposite. So I want you to start thinking of opposite here. So when you're dealing with a function, first of all, you're going to find f of negative x, then you compare with f of x, the original function. If f of negative x is the opposite of the original function, then f of x is odd. All right, now let's look at some problems. It sounds horrible, but it is not that difficult. So let's look at some examples, and you're going to see how easy this is. All right, so the question is going to be this. Determine if each function is even, odd, or neither. And it's going to look like this. And when I say neither, it means neither even nor odd. That's all that means. So the neither means it's not even and it's not odd. Okay? So let's look at number 1. Let me quickly find those problems. I keep losing those problems. All right, here we go. All right, let's look at this one. All right, watch carefully how this is going to work. So let's do this one. F of x equal 9x to the 4th minus 3x squared. So here's a question. I want to know, is this function even, odd, or neither? Okay, first thing you're always going to do is find f of negative x. First thing. So step one, find f of negative x. But remember, in one of your topics that you learned, you had to find f of negative x in one of those topics. So wherever you see the variable x, you're going to substitute negative x. That's what this means. So this becomes 9 times negative x to the 4th minus 3 times negative x squared. And then you simplify. Negative x to the 4th is, this right here, is 9x to the 4th. Negative x squared, that's right here, is 3x squared. So negative x squared is x squared. So f of negative x is this. All right, so f of negative x is this. Now, that's step one. Step two is to compare f of negative x with f of x. Well, I want you to notice something. F of negative x is this. Okay, watch. F of negative x is this right here. 9x to the fourth minus 3x squared. F of x is this original, right? Write it out. 9x to the fourth minus 3x squared. What do you notice about them? They are equal. So if f of negative x equals f of x, then you say f of x is an even function. That's why I would do this. So step one, find f of negative x. Okay? Step two, you compare. So what I would do first is I would write f of negative x, put what I just found it to be right here. Then say f of x, right under that, put what f of x is, that's the original, and then compare them. You notice those are equal, so these two are equal, so then it's an even function. Okay? Now, let's look at number two. So number two, let's suppose we had this one. Let's suppose we had f of x equal negative x cubed plus 3x. Negative x cubed plus 3x. So step one, again, you want to determine if it's even, odd, or neither. Step one, you always have to find f of negative x. The first step. Whenever you determine if a function is even, odd, or neither, you got to find f of negative x first. So wherever you see the variable x, you're going to substitute negative x. So this becomes the opposite of x, put x in, negative x in parentheses, cube it, plus 3 times negative x. Simplifying this, a negative x cubed, this part right here, without the parentheses means this. So you're going to say negative, and then this becomes a negative x cubed like this now. Notice where I have the parentheses. I have the parentheses on the outside. So negative x cubed, where the negative x in parentheses means the same thing as this that I just wrote in parentheses right here. And then a positive 3 times a negative x is a negative 3x. And now here's where some students are going to get confused. You got to remember what this means right here. This right here means the opposite of a negative x cubed. The opposite of a negative x cubed is a positive x cubed. This is a positive x cubed now, and then minus 3x. Okay, so that was step one. Step two is compare f of negative x with f of x. So compare, step two, compare f of negative x with f of x. All right, so here's f of negative x. We just found it. That's this right here. So that's x cubed minus 3x. Here's f of x. That was the original. The original, which is this one. Negative x cubed plus 3x. What do you notice about these two functions right here? Are they the same? No, they're not the same. You can see they're not the same. That's x cubed, that's negative x cubed. That's negative 3x, that's positive 3x. But you notice they're opposites, right? So this right here, f of negative x, is the opposite of f of x. Because if you take f of x, which is this right here, okay, and you change the sign, you get this right here. Look, the opposite of negative x cubed, positive x cubed. The opposite of a positive 3x, negative 3x. And so now that they're opposites, you're going to say this. You're going to say answer, f of x is an odd function. It is not an easy thing to understand. I understand that. I know that. It is not easy to understand. All right, let's look at another one. Let's do another one. All right, let's do this one. Number 3, g of x equals negative 6x to the fourth minus 7x plus 4. So you would determine this if this function is even, odd, or neither. So step one, remember, is to always replace. Step one, replace Now, since I'm talking about g of x, I'm going to say replace g of x, or I'm sorry, find g of negative x. So step one. So instead of saying find f of negative x, because my function here was f of x, here it's g of x. So let's find g of negative x. Okay, so wherever we see the variable x, I'm substitute negative x, right? So I only see x listed twice right here. So this becomes negative 6 times the negative x to the fourth minus 7 times the negative x, and then plus 4. So again, what we did was wherever I saw the variable x, I substituted negative x. Now we got to simplify. So we're going to simplify this piece here and this right here. So I want you to notice that negative x to the fourth in parentheses means the same thing as x to the fourth. Because a negative times a negative times a negative times a negative is a positive. So this becomes negative 6x to the fourth. And a negative 7 times a negative x is a positive 7x, and then plus 4. So that is g of negative x. So that's what we just found. We just found g of negative x. Now, step 2 is to compare. Compare g of negative x with g of x. Compare what you just found with the original. That's what you're doing. You're comparing with the original. Okay? So remember, g of negative x is what I just found. It is negative 6x to the fourth plus 7x plus 4. G of x is the original. Negative 6x to the fourth minus 7x plus 4. Okay, now ask yourself this. Are they the same? No, they're not the same. Because remember, in order for them to be the same, every term has to be the same, right? Notice this, the x to the fourths are the same term. The const is the same term, but the x's are different, right? Okay, so they're not the same. Are they opposites? No, they're not opposites, because in order for them to be opposite, in order for these two functions to be opposite of each other, negative 6x to the fourth just better be a positive 6x to the fourth, and it's not. So those are not the same because of this right here. That's the only one that's different. And so therefore you're going to say, since it's not the same, so notice g of negative x does not equal g of x. So you're going to say g of x is neither even nor odd. Okay? All right. Let's do one more and then we'll end it. Number 4. So let's do this one. So number 4, you may see something like this on my math lab. So I'm just gonna put that out there. F of x equal 8x squared plus the absolute value of 8x. Don't let that absolute value throw you off. Listen to what we're about to do, okay? Don't let that throw you off. So you want to determine, is this function even, odd, or neither? So remember, step 1 is to always find f of negative x first. So wherever you see the variable x, I'm going to substitute negative x. Wherever you see the variable x, I'm going to substitute negative x. All right, now listen to what you're going to do. So you're going to say that's going to equal 8 times negative x squared plus the absolute value. Don't throw that absolute value symbol away. 8 times negative x, absolute value of that. Okay? Now, you're now going to simplify this and this. Okay, now listen carefully. A negative x times itself is x squared. So that becomes 8x squared. Plus, now listen carefully, I'm about to tell you. Okay, here's how you're going to do this. I'm going to work that out right here. All right, so I'm going to say this. 8 times negative x means, the absolute value of that means the same thing as saying negative 1 times 8x. Y'all agree? Negative 1 times 8x is this right here, right? You'll also agree, listen what I'm about to say, you'll also agree that I can write this as the absolute value of negative 1 times the absolute value of 8x. So the absolute value of this product I can write separately. The absolute value of negative 1 times the absolute value of 8x. But we know that the absolute value of -1 is a positive 1. So 1 times the absolute value of 8x becomes the absolute value of 8x. This right here is the same thing as this. So I'm going to rewrite this as absolute value of 8x. That right here, here's the work, is this. Now, you got to compare. Step 2 now is to compare. Compare f of -x with f of x. Well, f of -x is this. That's what we just found. That right here. That's f of -x. 8x squared plus absolute value of 8x. And then f of x is the original. 8x squared plus absolute value of 8x. What do you notice about those two? They are exactly the same. So since f of -x equals f of x, then f of x is even. F of x is an even function. All right, so it is 5 minutes after our time that we're supposed to end. It is, I agree, I understand this is not an easy task. It is difficult concept for many students to get right away. As I said, right away. All right, so just go back over this. I have other lessons in the module for you to look at as well. So just do the best you can with this. All right, but on the final, there may be one in the final. They don't always ask this on the final. But if you are going into another course, math course, beyond this, then you need to understand the idea of testing for symmetry. Okay? All right. Okay, guys, so do the best you can with this. This was the one on determine if a function was even, odd, or neither. All right, so I'm going to end this one.